Hi. This chapter, set theory, or this subject set theory, is very important and it is also very fundamental, and that's why it is very important. What is a set? Set is a collection of distinct elements. Okay, so consider anywhere where you have different elements that are distinct, you can think of it, all of those elements, and you can fit it into one place. Okay, then you name it, that is a set. So you are just concerned with the elements, you are just concerned with the distinct elements, and not in the order that you are collecting them. So this is what a set is. A set is a collection of distinct elements. For example, think about university. In the context of university, all students are distinct. Okay, so you can just put all of the students into one entity and call it a set of students. You want to pet a cat, and you go to a shop, and you ask the shopkeeper, what are the different breeds of cats. Now each breed is distinct, and because all of the breeds are distinct, then you put them into one entity called as breeds of cats, and in it each element is nothing but the different breed of cats. And set is very important, because building upon set theory, other concepts are derived. For example, the counting principles. Okay, in combinatorics, we will see that in combinatorics we are looking to find out the ways of doing things, in what ways, in how many ways you can achieve this operation, achieve this task. There also, each way is one distinct element. Each way is one distinct element. Let's say you have to perform two tasks, task 1 and task 2. And if you perform both the tasks, if you perform both the tasks, task 1 and task 2, then your objective is supposed to be fulfilled. Now there is a set which includes the ways to perform task 1, and then there is another set which includes, which every element of it is the ways to perform task 2. And we will see in the combinatorics that the total number of ways to perform, to achieve your objective, is going to be the number of elements in task A in task 1 multiplied by number of elements in task 2. Actually, this is very basic fundamental principle of counting, and this is mostly, it is very commonsensical also. But you will see that the set theory is the base for all of those. Even in computer science, in the subjects of theory of computation, entire theory of computation is a set membership problem. When I will start theory of computation, you will see that a language is a set of strings, and the whole of theory of computation almost is nothing but you are given a word, and you have to find out whether this word belongs to the language or not. What it really means is that whether this word is an element of this language, where language is a set. So in combinatorics is built upon set theory. In your theory of computation, because set is very fundamental. Set is just a collection of distinct elements. Like I've given you many examples. Everywhere where you find a distinct elements, and you are not, and their order is not your concern. That, oh, which element should be kept first, which element should be kept second, in what order. Order is not a factor. Then the collection of such distinct element is a set.